Hello, I'm Dr. Park Jung-chul. Regrettably, this is already the last lecture of fixture. As this is the last lecture, I try to make it more informative, and I hope you would enjoy this lecture. Let's begin. Today, I'm going to talk about implant surfaces. If you look at the advancement of implant surfaces, let me explain in the chronological order. Surface of implant. The first generation surface was a simply cut, machined surface. The second generation surface was made rough to increase the surface area. The third generation surface, the titanium's rough surface chemical properties were changed to accelerate the healing of implant. In the future, we'll have the fourth generation surface to have better outcome with the biological properties. How and why the implant surfaces have been evolved? Definitely, there are reasons for that. So today, I'm going to look at how and for what purposes the implant surfaces have evolved. First, let's look at the first generation implant surface. At the beginning, Brennemark implant adopted the machined surface. Just the titanium was cut for the surface. Due to the property of titanium metal, it forms in a living body a stable oxide layer which delays elution of titanium ions, improves biocompatibility, is strongly corrosion resistant to blood or saliva, leading to osseointegration without a special treatment on the surface. The roughness of machined surface is determined by the cutting and the strength of titanium. It differs from journal to journal, but the average machined surface roughness is about 0.5 to 0.8 micrometer. The smooth machined surface success rate is about 80%. Under today's criteria, the figure is very worrisome. To enhance the success rate, the second generation implant surface emerged. The second generation implant surface has the characteristics is that it has better bone-to-implant contact. So the surface is made rough. There are two ways to do so. One is to attach rough particles on the surface of titanium, and the other way is to roughen the surface by cutting. The first rough surface was made by Straumann in the 1970s. It was TPS surface with attached particles, followed by RBM, which had rough surface by cutting. Now, SLA surface is mostly used. The first rough surface, titanium plasma spray surface. TPS surface is coated rapidly by spraying titanium particles at high temperature. Compared to the machined surface, the rough surface had 6 times more surface area. It had superior stability and improved osseointegration. However, the too rough surface, when it is exposed, it was very challenging to clean the surface, so bone resorption accelerated. Also, during TPS fixture placement, the titanium particles fell off to surrounding bone or tissue, so the outcome of the particle-attached rough surface fixture was not as good as expected. So a method of roughening the surface by spraying a medium of specific particles on the implant surface, RBM, emerged. What you're seeing is the blasting on the surface of implant in this video. a certain medium is sprayed on the surface of implant. After the blasting, the smooth surface is turned into rough. But there's variation from paper to paper. Compared to the machined surface, it has the effect of increasing the surface area tremendously. But RBM did not meet the expectations where the bone quality is not very good. So they developed SLA surface with a rougher surface and the roughness the cells would like. After the blasting process, acid etching process is added. So through the 2 stages, the surface is roughened. Currently, to roughen the surface, most companies adopt this SLA approach, but the quality varies from company to company. To make the SLA surface, first the blasting is used to create craters, and the acid etching process creates micropits. Through the 2 stages, implant surface roughness is much higher than RBM. Increase of the roughness brought 45% increase in the surface area and bone to implant contact area. Such increase in the surface area is increasing the bone to implant contact, leading to more solid osseointegration. If you look at the clinical case, at 15 and 25 locations, RBM fixtures were placed with the sinus lift, but osseointegration was not achieved. Therefore, they were replaced by SLA implants and it became successful. As you can see in the case, the SLA surface with more surface area brings better osseointegration, and the removal torque is much higher than RBM. Therefore, SLA approach is adopted by most companies to make the surface rough. Next, the 3rd generation surface. It is characterized by making chemical properties of the implanted surface changed. The first method is to use HA, hydroxyapatite, which has the same composition as bone, to facilitate osseointegration. Plasma spray coating is used, or a nano-HA coating, or nano-calcium phosphate coating is used. The second method, hydrophobic implanted surface, is turned into hydrophilic property so that blood can adhere to it. Regarding those 2, let me explain. First method, HA coating. As you can see in the picture, HA powder is sprayed on the titanium surface to do the coating. It was started around 1984. The initial bone reaction was pretty good, so many companies adopted that method. However, 5 years post-op, the coated layer dissolved in the body, so they fell off. Such implants became mobile and fell off. Therefore, they no longer made the implants anymore. If you look at here, I placed HA-coated implant at number 36 in 2011. 7 years later, in 2018, the patient came back complaining the mobility of the implant. There was no gingiva inflammation or no bone resorption on X-ray. When HA coat is detached, usually no sign of inflammation or bone loss. Superstructure is removed. Fixture driver is connected. With a force of about 10 Newton centimeters, the fixture was turning. Super hydrophilic implant was placed, which will be discussed later. there's hardly any bone loss, and the fixture was cleanly removed. As the coated layer was absorbed, the fixture was removed very cleanly. The second way of using HA, the more uniform coated layer can be made to increase the adhesive strength of the coated layer. If you compare these two coated layers, left layer shows much more uniform layer, which increases the adhesive strength. Therefore, fixtures do not need to be removed as you saw in the clinical case before. The second way to change the chemical properties of the surface is to provide a super hydrophilicity to the rough surface to enable the blood wetting property. Fast blood clot formation enables early osseointegration. Locally on the market are Osstem CA-BA, Straumann SL active products. Compared to the conventional surface, blood wettability is much better. In order to acquire super hydrophilicity, first, SLA surface fixture is soaked in calcium solution to treat it with calcium ion. Then hydrophobic fixture would turn into hydrophilic fixture, attracting more blood. Calcium ion treated surface has better protein adsorption than the conventional surface. The higher the protein adsorption rate, the better signaling to bring cells to the site, facilitating healing. Fluorescent staining shows much higher protein adsorption rate than the conventional surface. The third characteristics of the calcium ion treated surface is more blood clot formation in larger area. As was explained in the previous lecture of implant healing, better blood clot formation leads to better formation of fibrin network, resulting in more stable and faster healing. Compared to the conventional surface, there is a big difference in the blood clot formation. We can expect faster and more stable healing than the conventional surface. The second way to increase hydrophilicity is the Osstem's BA surface. The SA surface is ultra-thinly coated with a bioabsorbency HA, and hydrophilicity surface technology is applied to increase early osseointegration performance, 30% improvement over the SLA surface. The degree of hydrophilicity determines the wettability of the fixture surface. The highest wettability is seen on the rightmost fixture, which looks wet with moisture. The fixture with increased hydrophilicity has very high blood adhesion property. This combines the advantages of SLA surface and HA bone response to improve healing and shorten the implant healing process. As seen before, HA surface has the advantage of good bone response, accelerating early healing, but the problem is the coated layer is absorbed and detached. By using ultra-thin HA, the detaching issue is addressed, and the ultra-thin coat of HA is absorbed by the bone remodeling process. Ultimately, the ultra-thin HA coat facilitates osseointegration and is absorbed during the bone remodeling process, overcoming the disadvantage of HA surface and sustain stable osseointegration for a long time. At the end of the day, the reason why we come up with this surface is that, as discussed in the previous lecture, the secondary stability process is facilitated and made more stable. By increasing bone-to-implant contact, more stable osseointegration can be facilitated as the surface treatment technology is evolving. Recently, other specific material is used for the coating to develop superhydrophilic surface technology. The blood wettability is accelerated. Going one step further, protein attachment ability is further increased. It will affect the cell formation, which affect the healing. More than 90% improvement in terms of protein adhesion compared to SA. So this way, the surface treatment technology is evolving quite rapidly. Blood clots can be more stably maintained in wider area, contributing to the osseointegration. Depending on the treatment done on the surface, there is a big difference in terms of the blood clot formation. Compared to the conventional surface, the advanced surface makes much more blood clots. Over time, you can see the difference of blood clot formation between these two in the containers. The blood clot formation facilitates the bone formation, shorten the implant treatment time. As discussed in the previous lecture, the implant healing curves, the secondary stability curve will become steeper, accelerating the healing time. Let's summarize the third generation surface treatment. Fixture surface chemical properties are changed in terms of changing the hydrophobic property to hydrophilic property. Then why do we need a hydrophilic surface? This is related to the previous lecture, implant healing process. Osseointegration is based on the formation of the blood clots and the new bone formation. Cells come into the site. New bone is formed between the implant and bone, and they get integrated together. At this time, if the implant surface is highly hydrophilic, blood easily attached to the surface, and protein will attach more. The signals to call cells in there will improve, and the energy on the implant surface rises, making the environment favorable to the cells. Ultimately, the time for secondary stability, the osseointegration time, will be shortened to reduce the time for implant treatment. To achieve these objectives, many companies made a lot of efforts, and I've explained such efforts and how development has been made toward that end. Now, one step further, let's talk about the future surface technology, the fourth generation surface. No such products are on the market yet, but a lot of studies are going on regarding the biological properties. For example, growth factors can be collected from a patient's blood to facilitate the integration between an implant and bone. If you cannot understand it quite right, PRF or PRP, that is frequently seen in the clinical setting, can be the examples. This concludes the discussion on the fixture surface. Let's briefly summarize what we have talked about today. Implant fixture surface can be divided into 4 generations. The first generation, machined surface. The second generation, the rough surface to increase the surface area. The third generation surface is changing the chemical property of the surface to facilitate the osseointegration. The fourth generation is working on the bioproperty of the surface. For the future, the development of the fixture surface aims to shorten the osseointegration secondary stability period to accomplish the stable healing. That is the purpose and meaning of the changes. Through 3 lectures, we talked about fixtures. What do you think? Fixture design and surface changes have contributed to stability and implant healing. Through the lectures, if you learn to choose appropriate implant fixtures for your patients, successful implant treatment has already begun. I hope you will have great opportunities. Thank you for staying with me until the last moment. Thank you.
끝까지 함께 해주셔서 감사합니다.